Hello everybody, welcome to the classes by Mrs. Monisha Nathpal. Today we are back again with another sum based on the topic mensuration. The question is, the radius of the wheel of a car is 28 centimeter. Find the number of rotations made by the wheel in order to cover a distance of 4.4 kilometer. Now let us assume this to be the wheel of the car. Now suppose I say that the car starts moving from this part where I have marked with a blue line. It starts moving from here, okay, and it covers a distance and get back to the starting point at here. So it started from here and ended over here. So this is the distance covered by the wheel in taking one complete rotation. So what was this when I started from this blue mark and covered this entire distance and I have come back over here? So what did I actually cover? For the circle, I covered the circumference of the circle. So the distance covered by the circle in one rotation is actually what? The circumference of the circle. Okay, this is the most important concept that we have to have while doing sums of this kind. That is, the distance covered by the circle or the wheel in one rotation is equal to the circumference of the wheel. Alright, so here in this sum, the radius R is how much? 28 centimeter. This is the radius of the wheel. So what will be the circumference? It is equal to 2 pi r, that is 2 into 22 by 7, that is the value of pi, into r is 28, this much centimeter. This is 4, that is 44 into 4, 176 centimeter. So what is this 176 centimeter? This is the distance covered by the wheel in one rotation. That is the distance covered by the wheel in one rotation. That is equal to 176 centimeter. So always remember, that is, the circumference of the wheel is actually what? That is the length or the distance that it covers in taking one complete rotation. So the distance covered by the wheel in one rotation is actually the circumference of the wheel, which is 176 centimeter for this sum. Okay, now it has covered a total distance of 4.4 kilometer. So the total distance covered is what? Distance covered by the wheel is 4.4 kilometer. So be very careful over here. That is, the distance covered in one rotation was 176 centimeter, and here this distance is in kilometer. So we need to change both of them in the same unit. So I'll change this to 4.4 into centimeter. What did we do? I have converted the kilometer to centimeter. So therefore, I have to find the number of rotations. So number of rotations made. So number of rotations made means to cover this much distance, it is taking one rotation. In order to cover this much distance, how many rotations it will make? So that is, we have to divide the total distance covered by the distance covered in one rotation. That is 4.4 by 176. Alright, so this will simplify. So 2500. So your answer is the number of rotations made by the wheel is 2500. Alright, so what did we do actually? So I said the very important thing to remember while doing sums of these kinds is that you have to remember that is the distance covered by the wheel in one rotation is actually what? The circumference of the wheel. So if the radius is given or whether if your diameter is given, whatsoever is given to you, you will first find out the circumference of the wheel. After you get the circumference, that means you have got the length or the distance that is covered by the wheel in one rotation. Okay, so the distance covered by the wheel in one rotation is actually what? The circumference of the wheel. Now, the distance covered by the total distance covered by the wheel was given to you, which was 4.4 kilometer. Now make sure the distance that is covered by the wheel and the distance covered by the wheel in one rotation, both are in the same units. Okay, so 4.4 kilometer means 4.4 into 1000 into 100, that is this much centimeter. So number of rotations made will be equal to 4.4 into 100,000 by 176. So once you cancel out things and simplify over here, you are getting the rotations as 2500. So the final answer is the number of rotations made by the wheel is 2500. So I hope this concept is clear. So this way you can do sums based on this, just keeping in mind the concept that I have to consider the circumference of the wheel as the distance covered by the wheel in one rotation. I hope I could help you in clearing your concept based on sums of this kind. I hope to meet you very soon in my next video. Please do subscribe my channel if you like my channel. Please press the like button. If you want to share, please share my videos. And if you want to really benefit from the videos, then please do subscribe my channel. Thank you. Hello everybody. Welcome to the classes by Mrs. Monisha Nathpal. We were doing the topic mensuration. Today I have come with another sum based on the topic mensuration. A wire is in the shape of a rectangle. Its length is 36 centimeter and breadth is 32 centimeter. If the wire is bent in the shape of a square, what will be the measure of each side? Also find which shape encloses more area. So the sum is there is a wire which has been bent into the shape of a rectangle. Say for example, I have taken this blue wire which I have tried to bend in the shape of a rectangle. So the length of the wire is 36 centimeter and breadth of the wire is 32 centimeter. Now the same wire is used, if the same wire is bent in the shape of a square. Now I have used this same wire to make a square. So you have seen that the same wire was used to make both the figures. So from the first part, what I can see is the first is the wire is in the shape of a rectangle. So the length of the rectangle is 36 centimeter. The breadth of the rectangle is 32 centimeter. Now what is the length of the wire? That is, if I find the perimeter of the wire, that will be the length of the wire. That is the boundary. What is the boundary? The outer length. And what was the outer the boundary made up of? It was made up of the wire. Okay. So the perimeter of the rectangle is 2 into L plus B, that is 2 into 36 plus 32 centimeter. That is 136 centimeter. Now the perimeter of the rectangle is what? The length of the wire. This is the wire and this is making the rectangle. So the length of the wire is actually what? The perimeter of the rectangle. So length of the wire is equal to perimeter of the rectangle, which is equal to 136 centimeter. Now the same wire was again used to make a square. What remains the same? The perimeter remains the same. Means why perimeter remains the same? Because the wire is not being changed. The same wire is used. The two different shapes are made with the same wire. So the perimeter of both the shapes is the same. So perimeter of the square will be what? This will also be equal to 136 centimeter. Alright, because the same wire was used here in this case also. So we have to find the measure of each side. So side of the square will be what? Perimeter by 4. Perimeter divided by 4 is 136 by 4 centimeter. That is equal to 34 centimeter. 34 centimeter, which is the length of each side of the square. Now till here we have finished the sum. Now also find which shape encloses more area. In order to find this, we have to find the areas of both the figures. So the area of the rectangle will be what? Length into breadth, that is 36 into 32 centimeter square, which is equal to 1152 centimeter square, whereas area of the square formula is side square, which is equal to, I have got 34 here, so 34 into 34 centimeter square, which is equal to 1156 centimeter square. Now from here and from here, what you can see, which figure encloses more area? The square encloses more area. So therefore area, which figure or which shape encloses more area? So the square encloses more area. So this can be used for different shapes. It can be a rectangle bent into a circle bent into a rectangle, or a circle bent into a square, whatsoever it is. The basic concept behind this is that the perimeter for all the shapes will remain the same. Reason being, the same wire is used to make all the shapes. That is the basic concept lying in this sum. So I hope your concept was made clear. I could help you out in clearing your concept in this sum. I'll meet you again in my next video. I'll come up with some more sums of this kind. Thank you. Hello everybody, welcome to the classes by Monisha Nathpal. Today we are back again with the topic mensuration. After part 1, I have come with another type of sum based on mensuration. Let us deal with the sum now. Two roads, each 3 meter wide, run at right angles through the middle of a rectangular park such that each is parallel to one of the sides of the park. If the park is 70 meter by 45 meter, find the area of the park excluding the roads. So this is one of the very common sums that we have been seeing or have been doing while doing the chapter mensuration. So let us imagine this to be the park. The black portion is the park. Now there are two roads which run at right angles. So these are the two roads which are running at right angles through the middle of the rectangular park, such that each is parallel to one of the sides. So here this road is parallel to the length, and this road, that is the vertical road which is over here, is parallel to the breadth. If the park is 70 meter by 45 meter, find the area of the park excluding the roads. This is the sum all about. So okay, now I'll just take down the figure over here. Okay, so this is the rectangular park where I have said this is road 1 and say this is road 2. All right, is that clear? Now, so I have to, my objective is to find the area of this portion, that is the area of the park excluding the roads. So the very first thing that we'll do is area of the rectangular park we'll take out. So that is 70 meter by 45 meter, which is equal to 3150 meter square. This is the area of the whole park including the roads. Now, area of road 1. Now you see over here, this road 1, this is running parallel to the length. So this road, for this road, this is the length of the road and this is the breadth of the road. Okay, so length is same as the length of the park, that is 70 meter and this is 45 meter. Okay, so 70 meter into, now what is the width of the road? The width of the both the roads is 3 meter. So this is 3 meter. So 70 into 3 meter, that is 210 meter square. In the same way, when I talk about road 2, so area of road 2. Now road 2 is parallel to the breadth. So we can take that to be as 45 meter into 3 meter. Why? Because here this is 45. Since this is 45, this is also 45. Now this is also 3 meters wide. So this is 3 meter. So that is equal to 135 meter square. Now, the normal thing that will come to your mind, ma'am, is that we will add the two roads and then we'll subtract it from the area of the park. But one thing you notice that over here, this will be better one. You see, suppose I have taken this road with these stripes and the other road I have taken with these dots. Now when I was considering this road, that is road 1, you see road 1 and road 2 has this portion common to both. This portion, this the interior portion over here, this is common to both. Why? You can see over here the figure itself is telling you there are stripes as well as there are dots. That means that portion is common to both the roads. Now when I was considering the road parallelly, means when I was considering the area of road 1, once I had covered this area. Second, when I was considering road 2, then also this area was considered. That means this portion was considered twice. So if I find area of both the roads, what it will be? 210 plus 135 meter square. This when I consider, here, the common portion was falling 2 times. The common portion was falling 2 times. As a result, we have to remove it once. Why? Because that was the overlapping part, falling 2 times. The area was covered 2 times. So what we'll do, we'll remove it once. Now to remove that area once, we need to know the dimensions of that portion. So you see, here it is 3, here it is 3, everywhere it is 3. So it's a square. It's a square. So the area of the common portion will be 3 into 3 meter square, because area of the square is side square. So 3 into 3 meter square. So this is equal to 345 meter square minus 9 meter square, which is giving me 336 meter square. So this is the area of both the roads. Now this area is actually area of this road, area of this road, keeping in mind that this portion is taken only once. We have used this condition and done what? The overlapping part which was taken twice while considering both the areas is removed once. So this portion is giving me what? Area of both the roads. Now 3/4 of the sum is done. Now we have to find the area of the park excluding the roads. So simple now. So therefore area of the park excluding the roads will be equal to what? Total area of the park, that is 3150 meters square minus 336 meter square. Okay, so what we are doing, we are finding the difference of the areas of the rectangular park, that is 3150 meter square minus 336 meter square, that is equal to 3150 minus 336. Two 2814 meter square, that is 2814 meter square, which is the area of the park excluding the two roads. So we'll just give a fast recap to the sum. So the very first thing that we did, we found the area of the rectangular park, which is length into breadth, which was 3150 meter square. Now I have named the two roads. The road which was parallel to the length, I have taken that as road 1, and the road which was parallel to the breadth, I have taken that to be as the road 2. So area of road 1, so the length of the road 1 is 70 and the breadth will be 3 meter because the roads are 3 meter wide. Okay, so 70 into 3 meter, that is your 210 meter square. Now area of road 2, this road. Now the second road was parallel to the breadth, and so the breadth was 45. So this one also has a breadth of, this one also has a length of 45 meter. So area of the road 2 will be 45 meter into, now since the width is also 3 meter for this road even, so it is 3 meter. So 45 meter into 3 meter, which is 135 meter square. Now when I want to find the sum of the two roads, you are seeing that this portion, that is, let me mark this portion for you. This portion, this was covered twice, which we will use this logic, that is, I will remove the area of this portion once from the sum of the two roads, so that I get area of the two roads devoid of any sort of overlapping part. So area of the two roads, now when I was doing 210 and 135, this common portion was falling twice. That is why I removed the area once. Okay, so how? 3 into 3, because this is side, everywhere this is 3 centimeter, this is a square, so 3 into 3, that is 3 into 3, that is 9 meter square. So 345 meter square minus 9 meter square is 336 meter square. Now this is the area of the roads. Now we'll do the last part of the sum, that is to find the area of the park excluding the roads. So that is finding the difference of the area of the park and the area of the roads. So 3150 meter square was the area of the park and 336 was the area of the roads. So their difference is 2814 meter square, which is the area of your park excluding the two roads. So I hope the sum is clear to you, and every part of the sum please go through the video once again, pause in between, look for the reason why this is happening, okay, and try to understand the concept of the sum. These sums can also be accompanied with another part, that is what will be the cost of cementing the path, so and so. So you know, when the rate of cementing is given or the rate of laying grass is given, whatsoever is given, so you need to multiply the area into the rate given in order to find the total cost. So I hope your concept is clear. I could help you out in clearing your concept. Thank you. I'll meet you again in my next video, coming up with some more sums based on critical thinking. Thank you. Hello everybody. Welcome to the classes by Mrs. Monisha Nathpal. Today I am here to discuss with you a very common chapter, that is mensuration. All of us have been learning mensuration from a very small age, from very lower classes. So there are few problems which we have been doing. We have been doing for a long time, but some of us do the problems without understanding why we are doing. Rather, some of us by heart the problem, that this is the pattern, we will do it in this way. Today I am here today to discuss about those common problems only in a detailed way. Why do we do this? So I have come with two sums now. So let's discuss these two sums, because these are very common sums which we usually deal with while dealing with the problems of mensuration based on rectangles, rectangle topic. So the first problem is, a rectangular lawn 60 meter by 47 meter is surrounded by a path which is 1.5 meter wide. Find the area of the path. So a very common problem. As soon as you read this problem, you must have recollected your memories where you have done this problem. Okay, so I'll just discuss basically using some teaching aids today. We'll see hands-on. So suppose you imagine this is the rectangular lawn. Okay, this is the rectangular lawn and it is surrounded by a path. So this white marked path I have taken to be my rectangular lawn, this path. And a path which is 1.5 meter wide. Say this is the path which is 1.5 meter wide and it is running outside the lawn. We have to find the area of this path. Alright, area of this path. So what can I do? What normally can come to my mind when I start dealing with this sum? You see, I can split it in two parts. This was my initial figure. Okay. So this is the lawn, this is the path. So how can I get the area of the path? If I consider two rectangles, so two rectangles are, first is the rectangle which was my lawn, second is the rectangle which is the lawn along with the path. You can see this. If I take it out, I'll just get the path which is my requirement of the sum. So what are we doing? What did I do? I have taken out the lawn's area from the area of the lawn as well as the path. So that is our objective. Okay. Now imagine this was given to you, the lawn. Dimensions of the lawn was given to you. This is the lawn whose length is 60, breadth is 47. Okay. So let me take the lawn whose length is 60 meter and breadth is 47 meter. Now you tell me, how can we get the outer rectangle from the inner rectangle? How is the outer rectangle obtained from the inner rectangle? So the outer rectangle plus these two parts, if I do, I get the length of the outer rectangles. To get the dimensions of the outer rectangle, this is lawn, or say let's say the inner rectangle. This is the outer rectangle, which is the lawn plus the path. Okay, so how can I get the length of the outer rectangle? So the path is 1.5 meter wide throughout. So if this is the length of the lawn or the inner rectangle, to this if I add the width 1.5 on both these sides, here I am adding, here I am adding. So as a result I am getting this length, that is 60 meter, 1.5 on the left side plus 1.5 on the right side. So this is actually what? 60 plus 3, 63 meters. So 63 meters is this length. Now this length and this length, they are parallel. Whatever is this length, same is this length. So the outer length or the length of the outer rectangle or length of the rectangle including the lawn and the path is 63 meter. Similarly, if I want to get the outer breadth, this portion, how can this be obtained? This means this one means this outer line means this line. So this can be the inner breadth plus the width on both the sides, on top and on bottom. So B is equal to 47 was the inner breadth. Now I'm adding 1.5 and 1.5 on both these ends. So plus 1.5 plus 1.5. So 47 plus 3 is your 50 meter. I hope I am clear in explaining how we got the outer dimensions. So in general, what you will do, if you are given the inner dimensions and you are asked to find the outer dimensions, to the inner dimension you add 2 times the width. You will get the outer dimensions, be it length, be it width. If you want to find the breadth or length of the outer figure, then you can do the inner figure's dimensions plus 2 times the width of the path given to you. That is the normal procedure, normal formula. So now what I said, what to get the area of this part, what we will do, area of the outer rectangle minus area of the inner rectangle. So area of the path we are finding, that is area of outer rectangle minus area inner rectangle. So area of the outer rectangle is how much? That is your 63 into 50 meter square minus area of the inner rectangle is your 60 into 47 meter square. Let's calculate this. So area of the outer rectangle is your 3150 and area of the inner rectangle is your 2820. So now difference we'll find out. (330 meter square). That is the area of the path. Now certain times you will also see that this part of this question is accompanied with some little part more, that is what will be the cost of constructing the path if the rate of construction is so and so given. A particular rate of constructing, or say laying gravels on the path or putting grass around it, whatever is given, the rate will be given and you will be asked to find out the total cost of doing that particular work. So when you know the rate and you know the area, you can simply find the product and get the required cost. I hope I am clear with the process. So what is the process? If the inner dimensions are given, in order to find out the outer dimensions, what do we do? Inner dimensions plus 2 times the width. Area of the path, what will we do? Like I showed you in the figure itself, that is from the outer rectangle you remove the inner rectangle. Inner rectangle here was representing your lawn and the outer rectangle was representing the lawn as well as the path. So the outer rectangle's dimensions we got over here. As a result, we'll find the area of both the rectangles and find out the differences, and thus we'll get the area of the path. Now you see, this was the first sum. The second sum is the rectangular park is given to you whose dimensions are this and this, length is this, breadth is this. Now there is a path 5 meter wide all around it, okay, the path being inside. So the path is inside. So what are we going to do? What are we going to do? In this, the outer dimensions are given. So I said you one particular thing, that is, I said outer dimensions is equal to the inner dimensions plus 2 times the width. So what will be the if? Now if this is the case for the first sum, now in the second sum we know that the dimensions of the outer rectangle is given. So rectangular park is so and so, has a path this much wide, all around it, the path being inside the path. Now the path is inside, that means I have to find the inner dimensions. So this is given to me, this is question mark, and I know the width. Okay, so this is also given. So how am I going to find out the inner dimensions? You make subject, you make inner dimensions as subject. So outer dimensions minus 2 times the width will be giving me the inner dimensions. So to find the inner dimensions, we will subtract the twice of the we'll subtract twice width from the outer dimensions to get my inner dimensions. Same thing you can see in this figure itself. That is, suppose the rectangle as a whole is given to you. The rectangle as a whole is given to you. As a whole is given to you. Now if I want to find this, so from the outer figure, from the outer dimension, I mean from the outer length, if you subtract the, this is the outer figure and the inner figure together is given. You see, if I want to find this white line, this horizontal white line, what it should be if I take it to the outer length, you see what is the relationship from the outer length. If I subtract the width from both the ends, if I subtract the width from both the ends, I get the inner length. So say here for the outer rectangle, the length is how much? 300 meter. 300 meter. The breadth is how much? 210 meter. So for the inner rectangle, the length will be how much? I said what? To find the inner dimensions, you will subtract twice the width from the outer dimensions. So that is 300 meter minus 2 times 5 meter. That is 300 meter minus 10 meter, 290 meter. 290 meter, and your breadth will be how much? Breadth will be 210 minus 2 times 5 meter, that is 200 meter. So I have got the inner dimensions. Now outer dimensions, inner dimensions both we have. So now the process will follow is, from the area of the outer rectangle, we will remove the area of the inner rectangle. So we will get the area of the path. So area of path is equal to area outer rectangle minus area inner rectangle. Okay, so outer rectangle has dimensions 300 into 210 meter square minus, this is the inner dimensions are 290 into 210 meter square. Okay, I'll just clear up the board a little bit so that you can properly view this. So this is equal to okay, there's an error here, this is 200, sorry. So this is 58,000 meters square. Okay, so now we'll find out the difference. 63,000 minus 58,000, that is your 5,000 meter square. So that is the area of the path. Similarly, you can get an additional part to this question, that is, what is the cost of laying grass, or what is the cost of putting gravels, putting marbles. The rate will be given, you have to find the total cost. So once you know the rate, you can multiply with the area that you have got over here, and you will get your required total cost. So I hope both the sums were clear to you, and practice these sums more. That is the basic logic behind the sum, which I said the outer dimensions is equal to inner dimensions plus twice the width. So that is the concept which you will use to solve sums based on these kinds of concepts. So I hope your concept is clear. Go through the video more and more. Pause every point and see what is the reason why we are doing it, and make sure your concept is clear. So once you understand the concept, sums of these kinds will not be very difficult in dealing with. So thank you. I'll meet you next in my video based on sums which need critical thinking. Thank you so much.